first thing I would suggest we do is we start by writing down the 3 trig identities at the very top of the. Alright, so I did the first problem. I rewrote cosine. Cotangent is cosine over sine. And then when I look here, I can see that the sign in the first fraction and the sign in the denominator of the second are going to be eliminated. Really, they're going to simplify to 1. I'm left with cosine equals cosine. Let's get started with the second one. Make sure you show all of your steps. Take your time as you distribute. Alright, so what can I do here? Well, I can rewrite this as 1 over the sine of x. And then the sine of top and the sine of bottom are going to simplify to 1. I have 1 over 1 is 1. 1 minus sine squared, if I come up here. If I want to achieve 1 minus sine squared, so 1 minus sine squared is equivalent to cosine squared. Number 2 is done. Let's look at number 3. Now, this is what I taught you at the very beginning of class. If you're watching the video. For number 3, please apply the new even and odd identity. For number 3, apply the new even and odd identity. So I have 1 plus the sine of x and 1 minus the sine of x equals cosine squared x. Now, how is it able to go from this form into this form? That's applying this concept of an even odd identity. When I distribute this, I multiply the fronts, multiply the outsides and the insides, and the last. Additive inverses in the middle. 1 minus the sine squared x equals the cosine squared x. Now again, 1 minus sine squared, as I showed in the last problem, is equivalent to 1 subtract sine squared is equivalent to cosine squared. Left side equals right side. Let's look at the next one. Now in this position, I recognize that on the left and the right, I have a tangent in both terms. So I'm going to factor out tangent squared x, and I'm left with cosecant squared x minus 1 equals 1. Let's make sure that's right. If I distribute, that's good, and if I distribute, that's good. Now, is there something that's equivalent? Is there identity that's equivalent to cosecant squared x minus 1? Let's look up here. Cosecant squared x minus 1 is equal to cotangent squared. So I'm able to replace this with cotangent squared x. Now I know that tangent squared is the same as sine squared over cosine squared. And cotangent is just going to be the reciprocal of that, cosine squared over sine squared. Okay, now I'll grab another color here. These don't just disappear, they're going to simplify into 1. And these don't just disappear, they simplify into 1. So I have 1 divided by 1 is equal to 1. Let's look at number 1. Alright, so let's look at this next one here as I adjust this. Number 5. I'm going to start by distributing, so I'm going to have the tangent of x times the cosecant of x plus the tangent of x times the cotangent of x equals secant of x plus 1. Now I know tangent is the same as sine of x over cosine of x, and I know cosecant is equivalent to 1 over the sine of x. Over here, I have sine of x rewritten over cosine of x. That's what tangent is equivalent to. And cotangent is the reciprocal of that. On the left-hand side, the signs are going to simplify to 1. And I'm left with 1 over the cosine of x. Plus, now on the right-hand side, the sine simplify to 1, and the cosine simplify to 1. 1 divided by 1 is 1. Another way to write 1 over the cosine is the secant. Alright, let's look at number 6. Alright, let's see, on top, I can see they both have a cosine, so I'm going to factor out a cosine, and I'm left with sine of x plus 1. Let's make sure I did this right. Cosine times sine, and cosine times 1. Okay, great. On the bottom, I'm going to factor out a sine of x, and I'm left with 1 plus the sine of x. Okay, now, sine of x plus 1 and 1 plus sine of x, they're the exact same things. Remember, when adding, you can flip the order. So these are going to simplify to 1, and I'm left with cosine of x over sine of x. And I know that cosine of x over sine of x is the same thing as the cotangent of x. Are you talking about number 6? No? Okay. All right, in this position, what are we going to do? I think I am going to start by doing the butterfly method or the McFarlane method. Remember, I always start top left and then down to the bottom right. So I have cosine squared x plus sine squared x equals, and then we multiply the bottoms, sine of x. And this symbol is achieved by what's in between the two fractions. I know cosine of x plus sine of x is equivalent to 1. So I have 1 over the sine of x equals the cosecant of x, and 1 over sine is the same as the cosecant of x. Okay, let's take a look right now at number 8. Now we can start on the left or we can start on the right. It's really up to us and what we choose to do. I think I'm going to start over here on the left. So I'm going to break this apart to the sine of x over the tangent of x plus the cosine of x over the tangent of x. And I want it to equal this. Okay, now I know this is the sine of x divided by tangent. Well, what is tangent? Tangent is sine over cosine. And this is the cosine of x divided by the tangent. And tangent, again, is sine of x over cosine of x. But when we divide, we turn division into multiplying. So cosine of x over sine of x plus cosine of x times cosine of x over sine of x. Now, on the left-hand side, the signs are going to simplify, and I'm left with just cosines. I need a little more space here. Oh, let's see if I can borrow from this area. So here I'm left with just cosine of x. Now, on the right-hand side, I have cosine of x over sine plus cosine as x squared over sine. And we can see that's exactly what I have on the right. So this is equivalent to this, and it works. Let's take a look at number 9. Let's take a look at number 9. All right. Now, when I write this, this does not become sine squared plus cosine squared. That's a big misconception. I'm going to write the sine of x plus the cosine of x. And I'm going to write this down twice. Sine of x plus cosine of x. And only because I'm running out of space, I'm not going to put this down right now. Now, I'm going to go ahead and I'm going to FOIL. So multiplying the fronts, multiplying the outside, so sine of x, cosine of x, multiplying the inside, sine of x, cosine of x, and multiplying the last, cosine squared x. Now, I know that this is what I'm going to be left with at the very end. Well, let's see here. I know that sine squared plus cosine squared is equivalent to 1. So these two combine to give us 1, and now I have two groups of sine of x, cosine of x. And that's exactly what I was trying to achieve over here. 1 plus 2 sine of x, cosine of x. All right, let's go down to number 10. Now I'm going to rewrite this as the secant squared x plus tangent squared x. Add secant squared x minus tangent squared x. Now this is all on the left-hand side, and I want it to equal what's on the right-hand side. Okay, so if I FOIL these out, I'd get secant to the 4th, and then the insides and the outsides would be additive inverses. One would be positive secant squared tangent squared, the other would be negative secant squared tangent squared. So they'd cancel out, and then the backs would be subtract tangent to the 4th. That's how I'm able to break this up into two groups. What I recognize is that secant squared subtract tangent squared is equal to 1. secant squared subtract tangent squared is equal to 1. So 1 times this quantity is simply secant squared x plus tangent squared x. And now we have the left side is equaling the right side.